Greetings and welcome to a lecture on multidimensional arrays. Be prepared to have a headache. All right, so in programming, it's a very common scenario that we need to have a grid of information, so to speak. So it could be a chessboard, it could be something representing all the pixels on the computer screen. It could be financial data, spreadsheet type situation, the multiplication table, aka your assignment. Could be a lot of things. The key thing is that grids are a very common thing that we need to represent. And so to that end, we can use multidimensional arrays to be able to represent this information. It's not the only way. You can use a single dimensional array to represent a grid of information. We will talk about that some other time. So, for example, if we're looking at our chessboard here, and I want to represent this chessboard in memory, it would be very easy to set it up as a multidimensional array. In other words, I have an array, I've got rows, I've got columns, however I want to set this up, but I've got this nice XY coordinate thing set up here, where I can set up the top left as 0, 0, bottom right is whatever the maximum value happens to be, in this case 3, 3. And then that makes it very easy to iterate over the values. I can set up nested for loops to start here, and so the inner for loop goes through here, outer for loop kicks to this, inner for loop goes through here, so on and so forth. It'll be very easy to set up. By the way, the reason why 0, 0 is in the top left-hand corner, you will see this a lot. It's not a universal thing, but it's extremely common. One, for graphics, 0, 0 is almost always in the top left-hand corner because back in the oldie days, we had things called CRTs, or cathode ray tube monitors, or televisions as well for that matter. And how they worked is you had little dots of phosphor that would glow different colors depending on what wavelength you hit them with. And you had this ray gun, basically, that would scan a ray starting in the top left-hand corner and sweep it across a row. Then it would move down to the next row and sweep it across, so on and so forth until it had swept across the entire monitor, forming the image. So the starting point was always in the top left, so that's 0, 0. In the case of printing out text data, we always start printing here, right? If I'm going to print out a line of text, I start in the upper left, so to speak, and print out to the right. Then I move down to the next line, print out to the right, so on and so forth. So by no means is it universal to have it like this, but it is very, very common. So let's take a look at some code. Now, unfortunately, this one's going to be all lecture, no follow along. There's too many moving pieces when it comes to multidimensional arrays to make it effective to try and do a follow along lecture when trying to cover this, because I need to make sure that everything is precise, exact, because it is, even for me, it is easy to make mistakes when it comes to multidimensional arrays. So to start off with, what if I wanted to make a grid of values that were just the XY components added together? So if I've got, 0, 0, 0 plus 0 is 0. This would be 0, 1. So 0 plus 1 is 1, so on and so forth. And if I look down here, this coordinate would be 3, 3. So 3 plus 3 is 6. What if I wanted to create that? Well, to start off with, the format for doing a multidimensional array is very close to the format for doing a single dimensional array. We have our data type, and then we have a set of empty brackets indicating that this is an array, and then we have another set of empty brackets. On a side note, you are not limited to just simply having 2 dimensions to your arrays. You can have as many dimensions as you need. It is not very common to go above 3 dimensions for arrays, just simply because there's not a lot of calculations that actually require that. But there is no technical limit, just how much memory do you want to actually allocate to this thing. So I've got 2 empty brackets indicating this is a multi-dimensional array, a 2-dimensional array, and then I say new int, and then I give these sizes. So in this particular case, I am doing a 5 by 6. Again, it's not universal, but the way I'm visualizing this as this table here is that my x values correspond to my columns and my y values correspond to my rows. It is very important to have a clear idea in your head of how you are representing your data when it comes to multidimensional arrays. Now, how can I go over this? How can I iterate through all of my elements in my arrays here? Oh, you notice I've got 2 versions. I have a nested set of for loops, one that goes columns, then rows, and then I have one that goes rows, then columns. As far as setting data or accessing data, generally speaking, it doesn't matter. As long as I keep in mind that columns are my x value and rows are my y values, as long as I keep that straight in my head, it doesn't matter. I can iterate through columns and rows or rows and columns, and as long as I'm putting in the correct variables into my brackets here, it's going to work. Also notice for my for loop, I'm not using the traditional int I, j, k values that you typically use for loops. In this case, I want it to be very explicitly clear that this for loop is for columns and that this for loop is for rows. And then I can make sure that I put the correct values in the brackets. It just makes it a little bit cleaner and easier to see when a mistake has been made. Now, for displaying the information, it matters. So here's the result. Here's what actually gets printed out down here. For that, it matters because, again, the first character I'm going to print out is going to be in the upper left-hand corner because that's how print works, right? When I say system.out.print, it's going to start here in the upper left and print to the right. So I need to make sure that I feed it data in the same order. And so since I'm going to do a row, then move to the next row, then move to the next row, my outer for loop is going to be on rows. So I have int row equals 0, row is less than 6, row plus plus. And then for my inner for loop, I'm going to have columns because within this row, I need to print each column one at a time. So that will be my inner for loop. So for int column equals 0, column is less than 5, column plus plus. And then I do my system.out.print. Do notice that I'm doing a print, not a print line, because I don't want it to automatically kick things down to the next line. I want to be in control of that. And so I'm doing system.out.print, doing data, column row, because again, x, y, and then putting in a space here just for readability. And then after I'm done with my current column, I'm going to do another system.out to put in a new line code to skip down to the next line. And so that is how this code here is generating this output. Moving on, what if we don't know how large the array is? Like here, I know it's a 5-6 array. So I can manually put in rows less than 6, columns less than 5 when I do my loops. But what if I don't know? And that's a very common scenario of needing to loop through an arbitrarily sized array. Well, let's take a look at demo A then. And this also helps illustrate why you have to be very careful on how you're representing your data. So the idea here is that I am printing out this little X pattern, which is right there. Let's bring that up a little bit. There we go. So I'm printing out this X pattern. And so if I'm looking at this in terms of this grid here, 0, 0 is X, and it goes up to 3, 0, because again, X is the first value, so I would think that this would be 3, 0. But. This is a perfectly syntactically valid way of declaring a multidimensional array, just like a single-dimensional array. So to kick back and review that real quick, if I have int square bracket junk equals 1, 2, 3, separated by commas, this is going to create an array of 3 elements. Hold on one sec. I'm going to get rid of Steam that I needed to have for Tabletop Simulator. There we go. No more pop-ups. So again, this is creating a single-dimensional array with 3 elements. It would be functionally equivalent to this line right here, obviously needing to go through and do the initialization. We can do the same thing with multidimensional arrays. So I've got string bracket bracket, indicating it's a 2-dimensional array. And the outermost curly brace is defining how many things are in this first thing here. And so I have 1, 2, 3. I have 3 things that I have declared. And inside of each of those, how many do I have? I have 1, 2, 3, 4. So this is a 3, 4 array. So the X and Y are reversed. Again, if I'm looking at this in a standard format, my X coordinate, which is 0, 1, 2, 3, so there's 4 elements there. But for this first value here is 3. That's my Y. You can see it right here. If I do a system.out.println on demo_a.length, because remember, .length is how we find, well, the length of an array in Java. That is going to tell me that demo_a.length, this first square bracket here, is 3. And if I take a look at the length of demo_a of 0, or 1 or 2 for that matter, it's going to tell me that length is 4. So this is a 3, 4 array. The X and Y are reversed. There's nothing wrong with that, but you have to be aware of it. So when I go to do my for loop to print it out, I have to make sure that I am doing row column. I still have the outer loop still row, because again, I need to start here, print out this row, then I need to print out this row, then I need to print out this row. So my outer loop is still row, my inner loop is still column, but my printout, I need to do row column instead of column row, because how the data was structured. This is what I mean by prepare to have a headache. Multidimensional arrays, you have to be very careful. You have to be very conscious with how are you structuring this data. In this particular case, because of how I defined demo A, it is a 3, 4. It is a y-x coordinate system instead of an xy coordinate system. Why does this matter? Well, let's say that you have a function to display an arbitrarily sized two-dimensional array. I have to make an assumption on this. Is this xy or is this yx? And the assumption is xy, because you're going to be using this for your 8 queens problem next week, and makes sense to use an xy format. So this uses xy. If I try and pass DemOA into showText, it will fail. And it did not break in, so I will... there we go. So we can see on the output, there it is. I was thinking of a different error that no longer occurs. So the output is incorrect. Notice it's doing this weird thing where it's like displaying extra lines. It's not crashing, but it's also not giving me the correct output. That's what DemOA should look like, not this. So it does not work. So commenting that back out and running it again, that is the format that it should give. So again, the point behind this, besides illustrating you need to be very careful about are you using xy or yx, is also showing how you use .length to do nested for loops when you don't know how long it is. So I do row equals 0, row is less than DemOA.length. That will get me the first bracket size. And then I do column equals 0, column is less than. Now you always, or I shouldn't say always, as best practice, you should always grab each individual row's length, because Java does permit uneven arrays. In other words, the first element of if I've got a two-dimensional array here, I could have it so that instead of 4, this one has 3, and instead of 4, this one has 5. That is valid syntax in Java. So there is no guarantee that everything has the second index has the same length for all elements. So you should always, for best practice reasons, do it like this. The current row, what is its length? So I've got column equals 0, column is less than DemOA of row dot length, and then I do system.out.print row and column. Again, because this is a yx instead of an xy. Now, display text will work on data because data is done in an XY format, so therefore it will work. Also, a quick reminder on function overloading, because it's been a little bit since we looked at that. I have an overloaded version of show text. I have one version that takes in strings, and I have one version that takes in integers. Again, remember, for function overloading, it is the signature, it is the parameter list that must be different. The return data type does not matter. It is the parameter list that determines overloading. So here my parameter list is a two-dimensional string array. Here my parameter list is a two-dimensional integer array. And so that way I can pass in data, and that's not what I wanted to do. I can pass in data and it works just fine. It prints it out. Obviously without the space that we did up here, because display text doesn't do that. And finally, just kind of to twist the confusion knife here a little bit, this will work with display text. It's still yx. That is very important to keep in mind. The way I'm declaring demo C here, it is still a yx coordinate system. But my y and my x are both 3. So it doesn't matter. It won't break. This is why it is very important when you are doing testing to test with multiple values to make sure things work correctly. Does it work with x and y being the same? Does it work with x being greater than y? Does it work with y being greater than x? You want to test all of these scenarios in your code to make sure that it's going to work correctly. Or, does it work if x is less than 0? Does it work if x is, what happens when x is max integer, like we saw with the prime calculation? Once you set x to max integer, trying to calculate all the primes up to max integer, it revealed a bug in the original version due to how integer overflow works. So, very important to always test, because if you just test one value and you happen to choose the right value, it could accidentally work, which is what's happening here. Demo C just accidentally works because x and y are the same. Okay, so the assignment. Pretty simple one, mainly just to get you used to working with multidimensional arrays before you need to start working on the 8 queens problem. Create a multiplication table from 1 to 9 and then display it to the user. So in other words, it should show standard multiplication table. So like, for example, first line should be the 1. So it should show 1, 2, 3, 4, 5, because 1 times 1 is 1, 1 times 2 is 2, so on and so forth. And the next line should be 2, 4, 6, 8, 10, because 2 times 1, 2 times 2, 2 times 3, so on and so forth, for the values 1 through 9. And then, like I said, display that to the user. Pretty simple. Some restrictions. You must use displayText.showText to display it. So if you are not going for the extra credit, you have to use, whether you want to use the int version or the string version, I don't care, but you have to do the show text, the displayText.showText, in order to display the information to the user. You are not allowed to do that in main.java unless you're going for the extra credit. We'll deal with that in a moment. And the multiplication must be stored in a 2-dimensional array. Yes, this would be very easy to do with a standard nested for loop and just printing out the results of the multiplications. If you do that, you will receive a 0. You must use a 2-dimensional array to store the values. Now, if you want some extra credit, you will need to create a show formatted text method that takes a 2-dimensional, again, either string. Let me just go ahead and modify that while I'm thinking of it. There we go. So create a show formatted text method, string or int, it doesn't matter. I would say int, to me, sounds the most logical, but your mileage may vary. So you can create a show formatted text method in your main.java. Make sure it's a static method, otherwise you won't be able to call it. and it must display the table lined up. So for example, without formatting, your lines might look like this. Notice how the 8 is getting shifted from the 3's line. For the extra credit, it has to look like this. Everything has to line up. So when it's fully printed out, it should look like a uniform rectangle of text. There should be no unevenness to the right-hand edge of the text. And obviously all the values displayed, I'm just showing the line of 3 and the line of 8 for example purposes. So again, multiplication table, 1 through 9. The first line should show the 1s, second line should show the 2s, so on and so forth. You have to store it in a multi-dimensional array, in a 2-dimensional array. And if you're not doing extra credit, you have to use displayText.showText. If you are doing the extra credit, you must create a show formatted text method that'll take either a 2-dimensional string or 2-dimensional int array, however you want to roll with that. That will then display the numbers in a lined up fashion. I have not covered how to do this. You will need to do research on how to format the text. And with that, that is everything. Good luck on the assignment, and I'll catch you on the next video.